Hello everybody. This video will be the first video in a series where we cover all the major factoring methods. Alright, the first method that we'll cover is called the greatest common factor method. Instead of spelling out what this means in general, what we should really do is just tackle some examples and see what the main idea is. Okay, so starting off with this example A here, we have a polynomial, just x squared plus x. So the first thing we do is we look for anything that's in common between the two terms. Well, as we can see there, this is the same thing as 1x squared. This is the same thing as 1x. We usually don't write the 1, but just for emphasis I'll write it here. So notice that since there's a 1 here and a 1 here, the largest number that we could pull out of either of these is just 1, right? So we don't really write anything with respect to pulling out numbers, but we can actually pull out a variable from each of these two. So looking at this term and this term, we have 1x squared, we have 1x. We can see that each of these terms contains x. This one contains x once, this one contains x twice because it's x squared. So what we can do is we can actually factor out an x, and I'll show you what I mean by this. I'm going to first write x because I can see we at least have that in these two, right? We at least have 1x. So I pull that out. And now what I have to do is I have to think, okay, I have x squared right here. What do I multiply by x to give me x squared? And the answer is just x, because x times x is the same thing as x squared. Next, I look at the sign in the middle. That's a plus sign, so I'll need a plus sign in the middle here. And I need to know how many times does x go into 1x. Well, that's like asking how many times something goes into itself. So something goes into itself once. Alright, so what we've just done, to reiterate, is we took x squared plus x, and we turned it into x times quantity x plus 1. We just took something that started off as a sum, and we actually broke it up into a product. This is factoring. Next, we'll look at this example here, B, 12x cubed minus 3x squared plus 6x. In this example, we can see that it's not just like with the ones that we had before. Now we've got a 12, we've got a minus 3, we've got a 6. So ultimately we want to pull out the largest number that divides each of these coefficients. So we've got a 12, a 3, and a 6. Well, the largest number that goes into all three of 12, 3, and 6 is just the number 3. 3 goes into each of these. So we can definitely factor out a 3. So I'll write equals 3. So that's how much we're pulling out so far with respect to the number. Now with respect to variables, we have x cubed, x squared, and x. So the most that we can pull out is just 1x, because, for example, we couldn't pull out x squared because this doesn't have two x's, it's just 1x. So we can really only pull out 1x here. And parenthesis. Now we need to see, now we're going to ask ourselves, what do we multiply by 3x so that we end up getting 12x cubed? Well, to get from 3 to 12, we need to multiply by 4, because 3 times 4 is 12. Next, we have an x here, but we have an x cubed here. So we need to get 2 more x's. We need an x squared term here, and when we multiply this out, we will end up getting 12x cubed. So that checks out. Next, we have a minus sign here, right? Minus sign right here. And then over on this side, we just factored out a positive 3x. Therefore, we need to throw in a minus sign here. Next, we see how many times 3x goes into 3x squared. Well, the 3 goes into 3 once, so we don't write any numbers. And then x goes into x squared x times. Lastly, we see that 3x goes into positive 6x just twice. Awesome. So that is that example, example B. Now we're on to example C. This one involves two variables, but just bear in mind the same exact thought process you'll use the exact same thought process. So if we're looking at this, we've got 4x squared y squared minus 2xy plus y squared. Well, if I'm looking at all of these terms, I see that there's a 1 right here that I didn't really write, but I'll write it for emphasis now. We see we have 4, -2, and 1 for the coefficients. And it turns out that the greatest common factor of 4, -2, and 1 is just 1. There is no larger number that divides each of these. So we really, we could write a 1 here, but I'm not going to do that. So really, we're done with the number part now. Now into the variable part, we have x squared, y squared, and we have xy, and we have y squared. So what we want to do is we want to pull out the greatest power of x from this and the greatest power of y from this, if possible. So looking at this, we've got 2 x's and 2 y's. We've got 1 x and 1 y, and we've got 2 y's, right? So notice, for one, that we can't pull out an x, right? Well, we could pull out an x from each of these terms, but we can't pull it out from this one. So we must pull out something else. Well, looking at the y's, though, here we have y squared, here we have a y, here we have y squared again, right? So we can pull out 1 y from this entire expression, and that's because there's 2 y's here, there's 1 y here, and there's 2 y's here. So we can pull out just one of them. And so when we do that, we need to end up with 4x squared y squared after multiplying by y. So of course we'll need a 4. We'll need x squared, and we'll need a y. If we multiply this through, we will end up getting 4x squared y squared. Next, we pull a y out of minus 2xy. Well, minus 2x is what's left over. Lastly, we pull a y out of positive y squared, so we just end up with a plus y. All right, so let's just briefly summarize what we did. We covered the greatest common factor method. We start by pulling out the biggest number that divides all of the coefficients in the polynomial. That's what we start with. In this instance, we had a 3 that we pulled out. And then we go to pull out the biggest power of a variable we can. And here it was just an x, because we had x squared, x cubed. And then we essentially figure out what must go on the inside, so that when we take that greatest common factor and multiply it through the expression in these parentheses, we end up getting precisely what we began with. So factoring is really just rewriting things in a different way. It's taking something that's written as this polynomial where there's plus and minus signs in between, and instead we take it and turn it into a product of polynomials like this.